in Kingston today. Today we're just learning about math, more decimals, and yeah, we had a good funny walk. It was on the Pico Walk. This is a nice building in Kingston, right by the lake, the Great Lake. And yeah, it's a fun time. Okay, see you guys soon. Bye.
Good morning, grade 5. This is Mr. B, and today we're just going to be looking at, we're still dealing with decimals, and we're going to be dealing with place value. So I think this is something you guys have already dealt with before, but we're just going to review the idea of place value and how our number system works. And I'll talk about a different number system in a moment and just show you that this is how our number system works. So you kind of have to wrap your head around this, and then it helps you to understand math a bit easier. So the first thing to know is that the way we notate math is it doesn't have to necessarily, I mean, in our system it has to be like this. But there's been other cultures and civilizations in the past that have done it different ways. But this one, the way we've done it here, seems to be one of the most efficient ways. As it wasn't like a creation of mine, or it happened somewhere like in the Middle East, I think, where it originates from. And this system is kind of spread throughout the world because it seems to be one of the most efficient ways to notate math. So, yeah, we're just going to go here and look at what we're talking about. So when we have a number like 4,183, what are we saying? Well, in a sense, we talk about these different areas here, different sections of a number, as place values. Each section in a number holds a value, and it shows us something. And when we look at a number like this, we can quickly tell what it's saying. And what is this actually saying? Well, it's telling you that there are 4 thousands, there's 100s, there's 8 tens, and 3 ones. Now, that might sound funny because in the tens we actually speak we say them in a different way. We say 80, right? But what is 80? If we take it, we break this up a little bit smaller. What is 83? Well, what it really is 8 tens, or it is. Basically it's 8 tens. And so you can say it like that, right? You can see this. 8 times 10 is equal to 80, right? So if you have 8 tens, you have 80. And then it's plus 3 ones. And so we put the 3 ones into this section and the 8 into that section. And so 80 is in the tens area. And then you have 100, which just means that you have 1 times 100. And that just shows you have 100. And then the 4,000 is basically like this, just 4 times 1,000, which equals 4,000, right? And in each of these spots, which are called place values, we basically go up by 10. So let's just take this at the most basic level, and then I'll expand it from there. The basic spot here, is 1, right? 1 is the kind of the middle and the basic area. So when we have 1, we just have 1. But if we have 10 ones, right, we have 10. And we can show this. This is how this notation system works, is that when you have 1, you just have a 1-digit number. When you have 2, you have a 2-digit number. When you have 3, you have a 1-digit number. 4, 5, 6, 7, 8, 9 is still a 1-digit number. The second you get 10 ones, you end up having a 2-digit number, right? And what this 2-digit number is saying here is that this part here, we are saying is letting us know that there is 1 10 in this number. And this part here lets us know that there are no extra ones. So there's no ones or 0 ones. So you just have 1 10, and that's 10. Now when you have two tens, right, we call that 20. That's 20. But it's really, that's a funny 2 tens, right, in a sense. So because 10 plus 10 is 20. And that's the same for everything, right? when we go from tens, if you have 10 tens, you will get 100, right? 10 times 10 is equal to 100. And what do we notice here? Now there's 3 place values, or 3 digits. And this one here now signals that we have 100. And that's just going over a block. And then when we have 10 thousands, right, or 10 hundreds, we get 1,000. And I think you can notice the pattern here. Every time we move over, it's like times 10. So when you have 10 hundreds, you get into thousands. When you have 10 tens, you get into hundreds. When you have 10 ones, you get into tens. So that's the way we do math. Now, I think everyone knows about the Romans, and Romans are pretty cool. And you can see their pretty cool armor here. Hopefully I've been able to add a movie in because I can't see that just yet, but I'm hoping we add something here to show you the Romans. So Romans are pretty cool, but they did numbers a bit differently. This is not going to be tested on this at all, but this is to show you that Romans wrote their numbers like this, right? You might have seen this before. 1, 2, 3, and then 4, right? And then 5 is like this, and then 6 is like this. And you see their system works a bit differently. They kind of have different symbols that they plop together, just like these are kind of symbols, but their symbols get plopped together and it shows you a number. So you can see this is 4 in a different way than we would show 4, right? We show 4 just like this, but they show it as kind of, this is the 5 symbol, and if a number is to the side of it here, that is kind of 1 below 5. And then if you have it here, this is just 5 regularly by itself. So this just tells you it's 5. And here, when a number is like this, it says that there's 1 above 5. But yeah, and that's obviously 6. Now, yeah, that's their math system. In the end, when you're actually doing large numbers, it gets pretty clunky and it's harder to read. So yeah, it makes things a bit more complicated than our system. Our system tends to work a little bit better. And that is just what everyone uses now. So we've got that. Now we're just going to move back, and we'll come back to that in a moment, okay? So we were just talking about the place value system, and now we're just going to talk about the intro to decimal fractions. Now, decimal fractions, if you'll guess, we love the number 10, as you've been seeing over the past few days. Decimal fractions are all those fractions that can be easily converted into decimals. So 1 over 10 is a version of a decimal fraction, and 1 over 100 is a decimal fraction, and 1 over 1000 is a decimal fraction, and so on and so forth. And it just keeps going up like that by tens. And so yeah, these are what we call decimal fractions, because these can be easily converted into a decimal with no hassle, right? We just can convert them pretty easily as you go. Oh, I should put a dot there and a 0. And it goes on and on and on. Now, yeah, these are what we call decimal fractions, and the idea is that anything that is kind of a multiple of 10, or 10 times 10, an exponent, I guess, of 10, is a decimal fraction. So it's the denominator that's really important here. So that has to be, like, basically what we'll be dealing with is tens, hundreds, and thousands. So tenths, hundredths, and thousandths. And yeah, so 2 tenths is still a decimal fraction, and 2 hundredths, 50 hundredths, 99 hundredths, 999 thousandths is a decimal fraction. And so yeah, that's basically the point here, just to kind of focus in on that when we're dealing with decimals, the fractions that we're often looking at are this, and we've kind of talked about this already, so I don't think this is any new thing to you. The other thing is, something like this is not a decimal fraction. So yeah, we got to be kind of careful there. That is not a decimal fraction. It's not easy to convert this into a decimal. So we'll go now right on to decimals. Speaking of decimals, here we start a new topic. So this is going to be about the place value of decimals. Now, what's cool about that, we kind of saw this part already. I've already shown this section here, basically. This is another drawing, but the same thing applies with our, as we saw, remember we saw that ones, there's 10 ones in 110, there's 10 hundreds or 10 tens in 100, and there's 10 hundreds in 1000. And the same thing applies after the decimal point. So here's the decimal point, and it's the same thing. That hundredths are 10 times smaller than tenths, and tenths are 10 times smaller than ones, or a 1 is 10 times bigger than a tenth, and tenths are 10 times bigger than a hundredth. And you kind of see this larger, smaller idea here. And yeah, so really what we're dealing with is that when you go to the left, the further to the left, the larger the numbers are going to be. And when you go to the right, the smaller the numbers are going to be. And they're always in these sections, right? These are, you can kind of think of these as little sections of a number. So when we're dealing with a number that is kind of, let's see, do I have a good one here for us? Yeah, well, I think right over here, I got a good number for us. So here we have a number with all the different sections, right? So that we just talked about how this is hundreds, and this is tens, and this is ones, and then we have the decimal point, and then we have tenths. So you see it's tens here and tenths over here and hundredths. So it almost goes backwards in like a symmetry. This is like a symmetry at the ones. There's almost like a line of symmetry when they go out, and if you have 1,000 over here, and you have thousandths with the THS at the end on this side. Now, yeah, this is the same concept that here, when we're writing it down, that these are hundredths, and that what we're talking about with a decimal, right, that when you have 10 hundredths, right, that's equal to 1/10. And just like this, so if this was instead 10 hundredths, right, if we were going to say, if I have 10 hundredths, that looks like this. And we've talked about in the past that that is equal to this, because when you add 10 hundredths together, you have 1/10 of a total. So because if you have 10 groups of 10 hundredths, you'll have a full whole, and if you have 10 tenths, you'll have a whole as well. So right, these are equal now, and that's why it's 10 times this. So if you have 10 hundredths, you'd have a 1 here instead, and so on and so forth. And when you have 10 tenths, you get a 1 over here. So I can show this simply by doing something like this. Let me just erase this for you. Right, so if you have 0.01 with a hundredth, and you go, the next one is 0.02, and then you go on, and you have 0.09. When you go up one more, when you have one more, so you have 10 hundredths, it is written like this, like we just showed. 10 hundredths is 0.10. And really, when we look at this, 0.1/10 is the same, right? You have the 1 in the same spot, 1 digit behind the decimal, and 0 just means there's no more hundredths afterwards anyways. So yeah, we can see that these are equal. Now the same thing applies to tenths, right? When we look at tenths, we're dealing with the same idea, that you have 1/10, 2/10, 3/10, and so on until you get to 9/10. And then when you have 10/10, right, you just get 10/10 is just this. You know, you have one whole, 1 ones, right? And just like we saw before, right, when you have 10 tenths, you have 1. You go into your ones column. When you have 10 ones, you go into your 10 columns. And it just goes up like that. So that's the main concept of what we're learning today. So yeah, I'd just like you guys to go work on your yeah, your workbooks. It's just one page for today. Oh, there is one last thing actually. Though you could have found this in your thing, but I may as well show it to you here. Sorry for the psych there about the end of the class, but this is kind of fun to play around with the numbers. So if I write a number like this down, 735, and I want to make these numbers change by placing a decimal somewhere. So to start off with, let's say I want the 5 in this number to equal 5/100ths. Well, what do I do with the decimal point? Well, if I put it here, what does this now say about this 5? Well, now, right, if this is what? This will be your 10, let's start properly. Oh, okay, this is going to be your, what, ones. And on this side, you're going to be in your tens, right? And what will this one be? Tenths. This will be your tenths column. And there we go. So is that 5/100ths? No. So where am I going to put the decimal? Well, if you guessed right here, then you are correct, right? So if you have 7.35, now this 5 is in the hundredths category, right? Hundredths category. And that is perfect. So that's how you can do it. So if you put if the dot's there, right, and then this is the tenths category, and this is the hundredths category column place value area, right? And this one, the 3 here now, is not a ones anymore. This is a tenths, right? Because the tenths always go 1 after the decimal point. And now what's the 7 when you have it like this? Well, the 7 is now in the ones column. And if you put if we set, for example, did 0.735, now the 7 is in the tenths column, right? Tenths. And this one, the 3 is in the hundredths, and the 5 now is in the thousandths category, which is our next lesson. So, hope you guys had a good time watching this one, and yeah, see you soon. Ciao.